All right, so thanks everyone for coming today. If you have any questions, just hold them to the end of the presentation and I'll go through it with you. The order of events today is just to go through this presentation, then we're going to go down on the floor and sort of physically show you guys what we do, and I'll answer as many questions as I can when we're down there. The guys are still working till about 3:20, so there'll be a little bit of noise. It's a fun office to work in. But they'll be knocking off shortly, and yeah, that should all be good. So in the event of an emergency, we just evacuate down through either of those stairwells down and out the front to the front garden. We haven't had an emergency here yet, so haven't had to trial that out, but if we do, just remain calm and follow us. There's nothing that I could see that would create panic here. So with that out of the way, there's toilets just downstairs. Underneath the stairs is the girls' toilets, and just on this side, as you go down the stairs, is the boys' toilets, and that's just on that end of the building. And yeah, we can get started. So here to talk to you today about electronic waste and sort of what we do as a company to try and combat that. So the problem we're trying to solve is obviously electronic waste. We believe it comes about through planned and perceived obsolescence. So when you buy a computer or a television, a new computer comes out or a new television with better stats, people usually want to upgrade because they want the latest gear. So that's one way that electronic waste comes about, because people just throw out perfectly good working equipment. Secondly, it comes about through just things that are planned to break, like, or they've got consumables that aren't easily replaced. So printers, for example, sometimes it's cheaper just to buy a new printer than it is to buy just the ink that's in the printer. So that creates a lot of waste in that process. And yeah, we get a lot of printers because of that. The high quality printers, we don't see that often, but we see a lot of inkjets. And thirdly, things just break over time. We're all human, we all consume. As much as we try and minimise our impact, we're here living on the earth. We will, if you're wanting to connect to the internet, you've got to use something, and unfortunately those things just don't last forever. So there's always going to be some form of waste, and what we're trying to do is to turn it more into a circular economy as opposed to just the linear, I forget what the fad word is, but the linear circular. We're trying to create a circular economy, so we're not just making stuff and throwing it into the ground. We want to make stuff, extend the life of it, and then recover the materials so we can make more stuff. Sorry, I just saw my neighbour. The problem with electronic waste is it's a bit of a toxic time bomb. If it's not handled correctly, or if it's disposed in an incorrect manner, it can create a lot of problems. You've got a lot of valuable materials tied up with a lot of hazards. So that poses issues for the third world, because if it's exported overseas, which it used to be just to whoever wanted to take it, because people will buy e-waste nowadays around the world because there is valuable materials tied up in it. But there's also all these hazards that are also tied up in it, and if you just focus on the good stuff and throw the other stuff in the river, you create a big environmental issue. If you put e-waste in the landfill, it can cause toxic leachate to develop in the landfill. So I'm not sure if you know, if you put food waste or anything that'll degrade, it'll turn into like a slush, and it turns into an acidic leachate. So you've got slightly acidic leachate running over things like lead in circuit boards and leaded glass, and mercury that's in the back lamps of laptops and the flat screen TVs and that. And all the other materials that's in electronic waste, that can dissolve into the leachate and leach into our soil and potentially into our groundwater. So you really want to use a precautionary principle and keep that stuff out of landfill. Even though landfills nowadays, they are pretty good, in terms of containment, but it's just one of the ones that if there's a solution to not put it there that removes the risk completely, it's a better outcome, in my opinion. So currently recycling almost depends entirely on export markets, and everyone's seen the war on waste and all of that that's going on, where people are saying, well, I don't want to take your waste anymore, and recycling industry in Australia is in dire straits at the moment because they don't have any output for the material they recover, so they're having to look at all options, and some of those options include landfill. So that's one thing that we're trying to turn around. We believe we can turn it around with good policy that encourages a local recycling economy to develop. Local infrastructure is another key one, so that's something we're trying to build. So put together machinery and processes which allow us to recover materials in a form that's usable for a manufacturer. At present, a lot of our stuff still ends up going overseas because that's where the manufacturing is. So if you think about it from a practical point of view, you've got all this material coming in, that material's got to go somewhere. People often don't connect the dots, they just think they put it in the yellow top bin and it's recycled, but there's a whole supply chain on the back end of that, and when you're talking the materials economy, it's very complex. And if you think about things in terms of manufacturing high quality products, there's a big process on the front end of that where people go through a procurement process to get it exactly the way they want it, so it performs how the engineers have designed it. So the same thing applies to the back end. So that's where for us we're trying to recover the high quality materials as opposed to just mash everything together and ship it overseas for further processing, which a lot of that still goes on, unfortunately, because there's no other, well, we haven't invested the time to bring the infrastructure we need here locally to actually turn it into those high quality products. And unfortunately, economics is the ruler of the world, and that's what's driving the recycling crisis. Pretty much anything can be recycled, it just comes down to how much from a technical point of view. Yeah, you can literally recycle anything, just some things might cost $1 million a kilo to recycle, so no one's going to do it. So there's always this grey scale of do we recycle it or do we not? And everyone's got a price which they'll say, yeah, I don't really want to do that. Even the greenest people out there. But we've got to do more than we currently are. So that's what we're trying to achieve. Electronic waste is an extremely complex waste stream. You can't see this flow chart. It took me ages to put together. Yeah, it's on PDF and you can zoom into it. I'm happy to share that with people, but it's basically showing you the downstream process of everything. So everything comes in. We split it up into about 50 different material types, and then those material types will then go off to secondary processes and possibly tertiary processes, and those people are all putting energy into refining the material so it can be reused. So it's a challenging waste stream to recycle, but you've got to start somewhere, and we think we're getting closer to end step outcomes. So just a bit on us. So this is how we started out. It's this is in 2008 or 2007 actually, before the company started. I think this is an old presentation, but we started just picking up stuff off the side of the road and trying to get the copper out of electric motors and things like that. We were working for about $4 an hour, and we realised that everything that we picked up, there was a heap of stuff that we couldn't actually recycle. So this is Dad's garage when he was over in Africa. We filled up his shed with electronics while we were trying to figure this out. And we were actually recovering working CRTs, so that's that clean stack there that we were trying to recycle or reuse rather than recycle. And for every working thing we got 2 non-working things. So we had to formulate a plan and go, well, what are we going to do with this material? we read a lot of books, we did a lot of research, and we figured out there are actual downstream options for the material once you break it apart, and that's how the business was born. So that's taking us, this is the old site, but basically you'll see the plant and everything set up there. That's sort of where we've come from to where we've gone to. It sort of just gives you an example of what can be done if you put your time and effort into actually trying to solve the problem. We're still nowhere near where we want to be, but we're on that path, and we're just going to continue to iteratively improve our process. So just to give you an idea on actual recycling rates in WA, there was us and one other company, now there's just us that does recycling, but back in 2008 there wasn't much electronic waste being recycled. We rapidly grew through 2009 through to 12 because of the digital switchover. Remember, everyone had to throw out, a lot of people threw out their TVs, so we got a spike in volumes. In 2012, we started our asset recovery division, so we believe that reuse is better than recycling, and we don't think we can recycle our way out of the problem, so we're trying to move up that supply chain. Up to 2018, we did 2,500 tonnes of electronics, which you'll see out there, and we recovered 20,000 assets and give them a second life. It's always better to reuse, because it means that if you go buy a second-hand computer, you don't have to buy a new computer, and all the resources that go into that new computer don't have to be pulled out of the ground. It's always a better option. So just quickly, there's our team, myself, my brother, and my father started the company, and then all our support staff underneath, they do a great job. So if you're ever recycling anything, you'll probably deal with one of these guys. So just to give you an idea on what 14,000 tonnes of e-waste looks like, which we've recycled over the last 10 years. That's these numbers of of different devices, so that's what we've actually had come through the door. And sadly, that's a lot less than what's actually been thrown out. Our biggest competitor is landfill, and we're trying to turn that around. There's a solution here, we just got to get people using it, because the more volume we can get, the better technology we can put in to get better recovery rates. We don't want people to consume more and just buy and throw out electronics. We just want them to stop throwing it into landfill and give it to us, basically, and we can then get higher quality outcomes. So this is 2017 numbers. I need to update this, but basically it gives you a rough overview of what we recover from the e-waste. So 66 tonnes of circuit boards, that's risen quite a lot, and it's going to rise a lot more with our optical sorter coming in. But that 66 tonnes, pretty much since November last year, we've recovered about 6 kilograms of gold out of electronics. So we recover the circuit boards and we send that off to Mitsubishi smelter in Japan, and they've got $1 billion smelter over there where they basically melt it all down. They use the resins as a fuel source, and then they recover the gold, platinum, palladium, silver and copper out of the circuit boards, and selenium. They don't pay us for selenium, but they pay us for the rest. So yeah, like recovering the circuit boards is a major reason that you want to recycle your electronic waste. To give you an idea, 1 tonne of circuit boards saves about 2,000 cubic metres of dirt being pulled out of the Kalgoorlie gold mine in terms of gold equivalent. It's between 30 to 100 times more rich in gold content than the gold ore that they're pulling out of the ground. So yeah, it's a really great outcome in terms of if you're looking at environmental impact or offset of environmental impact. Circuit boards is like a really good bang for buck in terms of saving the environment. So in that, 6 kilos of gold, roughly 42 kilos of silver, and about 16 tonnes of copper from the circuit boards alone. We get a lot of copper from other things like electric motors and PVC cable and all that sort of stuff. We've recovered 850 tonnes of ferrous metals, so that's things like steel, pretty much. So if it's a ferrous metal, it contains iron, and represents roughly about 40% of the waste stream, and it's something that we can recover quite easily. 189 tonnes of non-ferrous metals, so things like aluminium, copper, brass, or alloys of those metals. Stainless steel is still ferrous, I guess. 11.5 tonne of batteries, and batteries is one of the important ones that we try and harp on for not just environmental reasons, but also just the economic cost of putting batteries into your yellow top bin. So I'm not sure if that many of you are aware, there's not too many people here, so I can show you out there a video of what happens to a lithium-ion battery if you crush it. It's like a flare essentially, it spontaneously combusts, and if that goes into your compactor truck with all your recyclables, all the things that you're trying to do the right thing by getting them recycled, and if a lithium-ion battery gets in there from someone else's bin, that whole truck catches on fire. And we get councils through regularly that say, yeah, we lost a truck last week. Like, it's cost the industry hundreds of millions of dollars in cost, which would offset the entire recycling scheme for electronics. So recovering batteries is a really important one. Not only does lead acid batteries contain a lot of lead, you've got nickel cadmium batteries with the cadmium and stuff in there like that. The lithium ion contains it. If they're broken open, they'll produce hydrofluoric acid, which dissolves your bones. So there's a lot of these extremely useful materials that if they wind up in the ecosystem, they create massive problems. So we want to try and recover that, and that's what we try and do. 144 tonnes of non-leaded glass, 85 tonnes of leaded glass. So in the old box-style televisions, which we still get a lot of them through, believe it or not, you'll have up to 2 kilograms of lead contained within the glass matrix of the CRT screen. So does anyone here have the old crystal, like fine crystal glasses? So typically a lot of them are made from leaded glass. It's the same stuff that they make the CRT screens out of. There's not that much of an issue if you are drinking from it, but be aware of it. But when it's crushed up in landfill, it's why councils actually started engaging us to recycle it. They were showing up, they were getting lead out of their leachate ponds and saying, well, we need to have a look at this. So by recycling the TVs, that 85 tonnes of leaded glass has essentially saved 20 tonnes of lead going into landfills around WA. There's a heap of other stuff that we recover, and I'll show you all that up there. So why do you want to do this? You're all here to learn, and like you guys are probably preaching to the converted because you're already here. But why, like if anyone asks you, why do you want to actually do that? The reason that you want to do it is because you want to leave the second generation something that they can be proud to, call home. We don't want to put all of our problems onto them. We've got to start doing more than what we currently are. We live on a planet that's finite. It's not getting any bigger. We need to manage the resources that we have efficiently so that we can keep enjoying the quality of life that we currently enjoy. Because at present the consumption of resources is a lot more than what can be sustained in the future. We don't want to create problems for that second and third generation when they grow up, that they have to I don't know, for many of you that have been to China, like you've got the air pollution and all that sort of stuff. You want to just keep our environment in a pristine manner so they can enjoy what we've enjoyed. That's pretty much what it boils down to. That's sort of why I try and relate it back to people, is just say, well, what sort of world do we want to leave our children? Got a photo of my daughter there, got another girl on the way, and Michael's got 2 kids. And it wasn't until I had kids that really hit home. I'm still quite young. When we started, I was 21 years old. And I'll admit, like, it was just exciting. We're starting a business, we were doing all these good things, but it wasn't until I had kids that I realised, well, actually, no, this is really, really important. So, yeah, basically we're trying to ban e-waste to landfill. South Australia's done it, Victoria's just put one in. ACT has a semi-ban, we're trying to get WA to do the same. Those states that already have bans in place, like South Australia, they're achieving twice as much recycling of electronics than we are per capita. So that's the effect that legislation has on our community behaviour. So we've got a what's it called? Petition on the website. Log on the website. There's heaps of stuff here. And here we go. You can take one of these. Ban e-waste to landfill. There's the address for the petition. If you can sign that, I think we're up to close to 2,000 signatories. Got a meeting with the Federal Environment Minister on Tuesday, so we're going to be trying to push that agenda for getting regulatory action in the space, because there's a couple of ways we can change behaviour. That's the consumer behaviour, but regulation has a really good effect if it's done properly. If it's done improperly, like it has been a few times, it can create these perverse outcomes, so they got to do it right. But that's sort of the journey that we're trying to go down. There's a quick photo of our team, and yeah, that's what we're trying to create, just that zero e-waste to landfill by 2020. This is a bit of an older presentation, so I don't know if we're going to make that, but we're going to try. We want to keep supporting local infrastructure. The more infrastructure we can build here, the more likely we are to actually recycle the stuff. We get good visibility. People can come and look and learn and go, why do you need to take that off when you put it in the bin? Or why is that? The thing we're missing in Australia is like the knowledge of why we need to do these things. And I'm a guy who loves to ask why. And I believe that the more people understand, the more likely we are to actually achieve the goals that we're setting out. You know, zero. There was a goal to have zero waste to landfill by 2020. That was 10 years ago. It's nearly 2020, and we're nowhere near. And I just think that's one of the things that's lacking. And we want to we want to help grow the economy as well and provide people with jobs. When before we were doing it, the e-waste was going into landfill. There are a couple of other companies that are doing e-waste recycling. But just to give you an idea, 10,000 tonnes of waste going into landfill creates 2 jobs. 10,000 tonnes of e-waste creates over 50 if you actually recycle it. So the people that are arguing the case, well, there's a cost to that. That's why we don't want to support it, because we want cheap electronics. In actual fact, by treating the electronics properly and recovering them at end of life helps grow our economy rather than shrink it. It's the next big economic growth wave, I believe. It's going to come through. I think that's why ScoMo is looking at it closely, because it will. It creates heaps of jobs. So yeah, that's the end of the talk. So we're going to go through out to the factory.